हेलो फ्रेंड्स, वेलकम टू द गेट अप्रोच। आज हम टॉपिक पढ़ेंगे लीड एंड लैग कंपनसेटर, जिसके शॉर्ट नोट्स आपको हमारी फेसबुक पेज पे मिल जाएंगे। तो आगे आइए पढ़ते हैं लीड एंड लैग कंपनसेटर। तो इसमें हम टॉपिक कौन कौन से कवर करने वाले हैं। हम सारे कंपनसेटर्स के बारे में पढ़ेंगे, लीड लैग एंड लैग लीड, ऑल ऑफ देम। उनके बॉडी प्लॉट, क्योंकि आजकल उससे रिलेटेड डायरेक्ट क्वेश्चन तो पूछा नहीं आ रहे, डायरेक्ट थोड़े से कॉम्प्लेक्स करने के लिए उन्हें बॉडी प्लॉट में जोड़ के पूछा जा रहा है। तो उसके बॉडी प्लॉट्स भी देखेंगे। उसके एक्सप्रेशन फॉर मैक्सिमम और मिनिमम फेज, ये बहुत ही इंपॉर्टेंट एक्सप्रेशन है। इससे बहुत सारे फार्मूला बेस्ड क्वेश्चन होते हैं, और उसके एडवांटेजेस एंड डिसएडवांटेजेस तो हमें पता ही होना चाहिए। तो पहले हम पढ़ते हैं कंट्रोलर कंपनसेटर। बेसिकली इन दोनों में मेन डिफरेंस क्या है कि कंट्रोलर करता है टाइम रिस्पांस कैरेक्टरिस्टिक्स इंप्रूव करता है, एंड कंपनसेटर फ्रीक्वेंसी रिस्पांस करता है। सो इफ वी look at the time response, we go for controller and otherwise compensator. Here we are only talking about compensator. So first of all, lead compensator, as it is already written here. So I will be talking about only important points. So here it is high pass filter. We'll see how it is high pass filter, zero near the, and what the most important thing is which comes first, zero or the pole. So in lead it is zero, okay, and it speeds up the transients and increases the margin of stability. Gain margin and phase margin is increased by this lead compensator. So this is the representation. Whenever we put a signal in a network of lead compensator, we just get a extra phase, and that is called the phase lead. Okay, now the circuit, the important thing about this circuit is that it is having RC in parallel, and output is taken about R2. So if we form the transfer function by using the voltage divider rule, so it will be given like R2 by R1 by S 1 plus SC. This is the Z1 that we calculated here, and this is Z1 is this total, and this is R2. So total resistance will be this total. So if we keep on solving this and taking common R2 by R1 plus R2, and you can see the calculations here. So here if we have taken R2 by R1 plus R2 as constant out, and we give it a new name, that is lead constant, okay, alpha. And here t is the time constant. It is R1 and C1, R1 dot C1, you can say multiplication of both of these. So transfer function will be, if we replace it by alpha, R2 that is R1 by R1 plus R2, so it will be alpha, let's see, R2 by R1 plus R2, sorry, and this will be alpha 1 plus st 1 plus alpha sf alpha t. So the important thing about this is alpha is always less than 1, and time constant is R1 C1. So if we talk about the pole zero plot, so pole zero plot will be what, minus 1 by t, that is 0 will be at minus 1 by t, and pole will be at, if we equate it to equal to 0, that will be minus of 1 by alpha t. So how can we decide which is bigger? We can decide it by this term alpha. As I said that alpha is always less than 1, because it is R2 by R1 by R2. So obviously it will be less than 1. So if it is less than 1, so on total it will be more, and if more of negative, it will be behind the 0. So minus of 1 by t and minus of 1 by alpha t. Okay, so body plot will be like this. Why? Because when we started, there will be a 0 first, and a 0 adds up 20 dB, we already know. So first there will be a 20 dB rise, because the 0 will be coming first, and after the pole will be coming, it will neutralize it. The plus 20 by plus 20 minus 20 is equal to 0, so it will be 0 after that. So it is basically why we say lead is high pass filter, because it is only allow it is the plot of like high pass filter has practical high pass filter we are talking about, and maximum phase lead. So this is the, this is the magnitude plot. If we plot the phase, then it will be like this, and this is the omega m is the point where there will be the maximum phase. And how can we calculate this? Maximum phase lead occurs we need to calculate omega m by multiplying both of the poles and zeros and taking the under root of them, and we will be getting the value that, at which the maximum phase will occur, that is 1 by t of under root alpha. Okay, in resonance it is having like this maximum phase. As in resonance, it's not a resonance, it's like a resonance. You can remember that in resonance also omega 1 and omega 2 we take the under root. That's why the expression for phi m is the angle that at which maximum phase occurs. So what is the expression? This is not the expression, that is omega m. Omega m is the frequency at which it occurs, but not the angle. So angle we need to calculate, and for that we just need the R transfer function and replace s by j omega and converting it into j omega plus real and imaginary form, and then taking angle will become easy. So after that we take the angle in form of tan inverse, and after after solving these of the equations, uh, we know that at omega equal to omega m only maximum phase occurs. So at omega equal to omega m we put the value of omega m here, that is 1 by t under root of alpha we just calculated, and putting it here phi m will be tan inverse of 1 minus alpha by 2 under root alpha. So but if we go it we know in the form of tan, but we want it in sine and cos, so we just need a triangle, right angle triangle. We know tan is p by b, so we put p by b and calculate the hypotenuse accordingly. And once calculated hypotenuse, then you can calculate sine and cos everything. So most used formula is sine pi m 1 minus alpha 1 plus alpha, because it is easy to remember. So you can calculate, and cos phi m also can be derived from this triangle only. So just remember one formula and you will remember otherwise others also. So alpha value now at phi equal to, if phi equal to phi m, so sine of phi m is equal to 1 minus alpha. This is one of the one other formula that you can remember easily in terms of phi m only. So phi alpha is equal to alpha, we are calculating here alpha. So from this expression we can calculate alpha by 1 minus sine phi m 1 plus sine phi m. Alpha is what? That is the what we are going to talk about here. Alpha is what is making the signal attenuated. So this is the main disadvantage what we are talking about, because this is always less than 1. This is less than 1 means the total transfer function will be becoming decreasing. So because of this only, so for that we connect a series component of 1 by alpha to cancel out this component, and this is the main disadvantage, because we need extra element to connect in front of a lead compensator. So so, so for that only we will be going to lag compensator. But before that, what are the benefits? We should say that bandwidth is increased and the stability is also increased. TR is the rise time that has decreased, and transient response has improved. Okay, these are the few things. We just need to remember bandwidth is increased and stability is increased. Okay, now phase lag compensator. Why we were talking about this? Because in the circuit there is a lag, that is minus phi is added after that we go through this transfer function. And how is this transfer function? Transfer function is this. In the most important thing in this is the output is taken along the series component of R2 and C2. So again voltage divider, if we apply, we will getting the transfer function. And here also we will be taking common something R1 plus R2 by R2, and doing that. Time constant is same as phase lead. R, like it was R1 C1, it is R2 C2 here, and beta like alpha was R2 by R1 plus R2 alpha. Here beta will be just inverse of that, but that is 1 by alpha. So we can write R1 plus R2 by R2. So it's almost same. So just don't get, just learn one thing. Just remember beta will be 1 by alpha, that's all. So if alpha is less than 1, obviously beta will be greater than 1 because it is reciprocal, and transfer function will be same, 1 plus st plus 1 plus s beta t. There was it is same as phase lead, but there was some alpha term out here which is not in present in this, so that's the benefit of lag compensator. So we will getting the poles and zeros, and as I said, beta is greater than 1, so obviously beta is if greater than 1, then the whole term will be less, and whole term will be less means poles will be the first one less, but in negative it will be closer to the axis or j omega axis. So this is the pole zero representation, and if we go, we know that as pole is coming first, oh sorry, यहाँ पे this is a 0. Okay, so this is the body plot of this. Why there is a negative -20? Because the pole is coming first, and after that a 0 is coming to neutralize it to make it equal to 0. That is because -20 plus 20 is equal to 0. And again a phase lag occurs at omega m, because this is the phase plot in BODE. And this phi and this omega m, again as I told, just multiply the other two other two poles and zeros location, and take the under root, and we will be getting the 1 by t under root of beta, same as everything is almost same in phase lag and phase lead. So now we can need to calculate the phi m. Phi m is, after phi m, we will be, for that again transfer function and then j omega, then we will be converting in tan inverse form. After that, putting at omega equal to omega m, putting the value at 1 by t under root of b, and we will be getting in the form of tan phi m equal to this. So again this triangle will be drawn, and we will be getting value of sine in terms of sine phi m, cos phi m, and the most easy is sine phi m, 1 minus beta by 1 plus beta. Okay, and from this formula we can calculate beta is 1 minus sine phi m by 1 plus sine phi m, everything almost same. So just remember one thing, and other will be remembered easily. But here the most important factor is no attenuation problem, because there is no alpha term in front of this, although it is in the denominator, but it is not on the in front of the numerator. That is why it is not attenuating. Okay. Now we will combine the lead and lag compensator. So it is lead and lags, that's why we will be the most lead compensator will be first and lag will be afterwards. So lead lag means first lead, and in lead the most important thing was that there was a parallel connection of RC, and in lag there is a not parallel, there is a series connection of RC. So first will be parallel, then series, and the transfer function will be for lead is this and for lag is this. So transfer function of for lead lag it will be just the multiplication of both of these, and then we'll be drawing the pole zero plot of this. So for first will come lead, so lead compensator will be there, and in lead there is 0 first, so that's why 0 and pole. Then lag comes, and lag there is a pole first, so pole and 0. Okay, so this is the pole zero plot. Then BODE plot will be, as there is a lead lag, so lead will be first, lead in lead 0 is first, so 0 plus 20, and then the pole will be raising it to 0, then again minus 20 due to the lag compensator, and lag will be having the pole first, so pole will be taking it minus 20, then again it is equal to 0. So this is the BODE magnitude plot, and phase plot again we can calculate it. Basically we are just adding both of the lead and lag terms, and we just need to focus which is coming first, and the other things will be calculated. Here there will be two phi's, where phi m1 and phi m2, maximum phase lead and maximum phase lag. And lead lag improves the steady state and transient state, मतलब basically दोनों को improve करता है ये. And it is band pass filter, as you can see this is only allowing a band to get through it, so it is band pass filter. And lag lead, the last thing is lag lead, and the most easy part is that lag, so lag will be having a series connection and lead will be having a parallel connection. So again we multiply the both of the transfer functions, and the pole zero plot will be of first lag, so lag will be having a 0 first, and then pole, sorry, lag will be having a pole first and then 0, and then lead will be having a 0 and then pole. So as it is having a pole first, so it will go -20, then 0 because of 0, and then again 0 0 is there, so it will taking +20, and then after that +20 will be neutralized and again it will be 0. And this is the omega 1 m1 and omega m2 can be calculated. See, just remember that omega omega 2 is the value of lead, and omega 1 is lag because it is lag lead. So just remember the formulas and it's all easy. Okay, I hope you like the videos, and please like and subscribe, and for PDF notes follow our FB page given in the description, and hope your preparation is going well. Okay, thank you and have a nice day.